All right, good afternoon, everyone. Thank you so much for joining us for this info session all about our Geographic Information Systems remote sensing program, or GIS remote sensing. It's a graduate certificate program here at NSCC, and we're really excited to share some more information with you about it today. I want to start first with a couple of important acknowledgements. NSCC is located in Mi'kma'ki, the unceded territory and traditional homeland of the Mi'kmaq Nation. Our relationship is based on a series of peace and friendship treaties between the Mi'kmaq Nation and the Crown dating back to 1725. As treaty beneficiaries, we recognize that we are all treaty people. NSCC also recognizes the African Nova Scotians as a distinct group who arrived here 400 years ago. From that time on, they have contributed to the infrastructure and economic wealth of the towns and cities they helped to build, but from which they could not benefit. Let us learn more about how our respective communities were shaped by the historical contributions of African Nova Scotians to Mi'kma'ki. All right, so like I said, thank you so much for joining us today. If this is your first time joining us for an info session, welcome. You'll see a control panel on the side of your screen or somewhere if you're on mobile. So for the duration of the info session, we won't be able to see or hear you, so you can just relax and enjoy the information. If you have any questions, though, we welcome those. You can use the questions box that is located in that control panel, and we'll go through those questions at the end of the session. If you think of anything after the fact, you can email recruitment@nscc.ca, which is the yellow email address on your screen. Or if your questions might be more personal in nature about your specific application, you can also email the recruitment team. Today is May 29th, 2025. So if you happen to be watching this later, either as a recording or anything like that, just know that information may have changed. So be sure to check our website for the most up-to-date information. But as of today, this is all accurate information. All right, so we do have two faculty members joining us today. My name is Jessica, and I'm a student recruitment coordinator here at NSCC. But I will allow Rob and Jim to introduce themselves to the group.
Good afternoon, Jessica. Thank you for introducing us. So my name is Jim, and I'm one of the faculty here at COGS, the Center of Geographic Sciences, and my primary role is with the remote sensing courses, but also with some of the other courses as well, such as Geographic Engineer and the Survey Technician program. With the graduate certificate in remote sensing, my involvement will primarily be in the second semester, and I'll be looking after the applied research project course, where we learn some project management. Also the remote sensing systems and applications course, which is where we basically take on a lot of abstract remote sensing techniques that aren't mainstream per se, such as radar, thermal, and other techniques as well. And also the airborne survey course, where we go through the whole gambit of how to plan and collect aerial survey by either plane, aircraft, or by RPAS or drone. Okay, over to you, Rob.
Thank you, Jim. Thanks, Jessica, and thanks everyone for your interest in the GIS remote sensing program. I'm Rob. A little bit of my background. Went through Memorial University in Newfoundland. Finished with a Bachelor of Science from there. Did a little post-grad GIS IT thing. Moved out west, that being Alberta, in '99, and worked in the industry doing various GIS, GNSS survey type of work, and then I found airborne LiDAR. Worked out there until 2014, and I moved to Nova Scotia and took this job with COGS, and I've been here ever since, and I'm loving it. Got to meet all kinds of interesting folks and feel the reward of students going out and getting good jobs when they're done. That's me in a nutshell.
Awesome. Thanks so much. These two are the real experts on this program, so we're really happy to have them with us today to kind of delve a little bit deeper into the program and share some information with you today. Just a little bit about NSCC in general, if you've never heard of us. So we're the Nova Scotia Community College. We're located on the east coast of Canada. One thing that kind of sets NSCC apart from other, say, universities or other post-secondary institutions is that we're very driven on graduate employment. So you'll notice that in our future slides is that we're preparing students, no matter what program, to be able to jump right into industry and into a rewarding career. We have 14 locations across Nova Scotia. We'll get into that on the next slide. And specialized programs. So this program of remote sensing is a very good example of one of those specialized programs. You're not going to find that program at every college and or university across the country. So it's very specialized. Hands-on learning, again, we'll get into that in a little bit. Small class sizes. So our class sizes, depending on the program, can be I'd say like maximum 30 students. Instructors with real world experience. So you heard Jim and Rob talk a little bit about their experience in the field. So they bring that industry knowledge into their classrooms. We have great facilities and technology, which I'm sure Jim and Rob will mention too when it comes to remote sensing. But all of our programs have really great access to state-of-the-art facilities. So like I mentioned, there's 14 campuses across the province, including an online eCampus. But for today, the remote sensing program is located at the COGS Center, which is kind of an offshoot of our Annapolis Valley campus. This program is delivered online, but it's based out of the Center for Geographic Sciences. So just a little bit about that campus. So the main campus, like I mentioned, the Annapolis Valley campus is located in Middleton, and then just down the road in Lawrencetown is where you'll find the Center for Geographic Sciences, most commonly referred to as COGS. COGS, like it says, is Canada's largest geomatics training institute, so very specialized programs that you'll find at COGS. And the student population of the entire COGS plus Annapolis Valley campus is about 360. So it is a relatively small campus, which has really great benefits to having a small campus. And just a little bit generally about this program. So it is a graduate certificate, meaning that students have to come into it having already completed a diploma or an undergraduate degree. It's a one-year program and it's synchronous online. So I know Jim and Rob will touch on this in a moment, but the courses are delivered online, but scheduled. And then there is an in-person component as well. Something important for any international attendees is that this program, finishing this program, would not allow you to be eligible for a postgraduate work permit, unfortunately. So when it comes to admission requirements, and I might ask Jim and Rob to jump in a little bit here, but the diploma or undergraduate degree has to be in a related field of study. So I've just listed which fields of study would be applicable. There are some programs at NSCC that would meet these admission requirements. So if you've already studied at NSCC, you can use that diploma towards remote sensing, or if you've completed an undergraduate degree in one of those fields, it would allow you to be eligible. I don't know, maybe Jim and Rob can speak a little bit on if there's a benefit of one field of study over the other, or if any of these are really applicable to this program.
Right. You're going to jump in first, Rob.
That's okay.
We haven't planned it out very well. Well, I think, you know, anything science-based or resource-based, we've had all kinds of folks come through. The last couple of years, we've had physics grads, you know, all these graduates, whether it's a degree from the university, some master students, it could be diplomas from the NSCC or other colleges. It's tough to say, I think, because I think what we teach could apply to a wide array of industries. You think, Jim?
Good to know.
Yeah, no, that's right. We had an astrophysicist just the other year, did very well. He's now working within applied research in geomatics. So any field really that has like Rob mentioned, is anything to really do with natural resource management in one way or another. That seems to be how we concentrate. Will have a benefit to coming here and getting the graduate certificate on basically how to do a real collection of data in order to enhance what they already know. So as an example, for instance, if you're a geologist and you want to upscale your skill set, then coming here will give you the skills to be able to then do remote sensing for geological kind of purpose. Same could be said for any of the other disciplines within the list here. And it's not exclusive to this list, but these are the kind of the recommended backgrounds. And we try to emphasize that the graduate certificate being like a short concentration of technical skills that is supposed to kind of take you to another place within your degree area. It's very much like that, but we're not specific to geology or to forestry. We're a bit more generalist. But we do ask that you apply your learning when you're with us to your previous degree or in the direction that you wish to go to in the future. So it is, you know, that kind of concentration of knowledge and very, you know, technical knowledge at the end of a period of learning.
Great answer. Sorry, threw you for a curveball early. But I will pass over officially to Jim and Rob now. They're just going to take you through some schedule information, classroom, field work, that kind of thing. So we'll start off with this slide and take it away.
Okay, I think this is essentially the schedule, a tentative schedule for the upcoming fall. So typically here we have 2 full semesters and then we have a spring semester. So the first term is very, it's a foundational term. So even if you don't have any of the geospatial or the geomatics type background, a lot of these courses are meant to give you that foundation. So when we move on to the second semester or the winter semester stuff, you've built a really strong foundation here in the first term. So I think the strategy here is we'll just kind of briefly touch on what the courses are so you have a little bit of context. So geodesy, that will be, you know, foundational stuff. You'll work with map projections, coordinate systems. It's all about, you know, think about taking coordinates from a spherical or a round object like the Earth and putting it on a 2D surface like a map or something like that. Lots of times when you do field work, there's a lot of different coordinate systems, so it's important that you have a good understanding of the different coordinate systems and transformations between them all. That's pretty common. You'll do that a lot. Of course, there's going to be an intro to GIS course, which has been kind of tailored for the remote sensing material. The instructor will work more with raster data as opposed to vector data, so more images, that kind of stuff. Again, that's a really important course, foundational stuff to carry on to the next term. You'll have an introduction to remote sensing and digital image processing, where we'll get to explore various types of satellite imagery, airborne imagery. We'll use a couple different pieces of software, and we'll talk about some theory of, you know, what parts of the electromagnetic spectrum can we use to our advantage for different applications. The GDA course, this is an intro basically to data analytics. I wrote some notes on that one because I'm not really that familiar with that one. GDA, I think the instructor in that one, it's an introduction to think like data pipelines. There's a little bit of statistical methods, I think, in that course as well. And so some of the stuff that you'll do in that, again, will transfer over to some of the courses that you will do in the winter semester, and maybe even a project or something in the spring semester. Of course, there's also going to be an intro to programming. That's basically, I think that's strictly Python, but there will be a lot, you know, if you're new to programming, don't worry, this starts out at an introductory level and it kind of ramps up as you go through the term, because writing scripts and some coding will be beneficial to you when you do some courses in the winter semester. And I'm sure, you know, in your future careers, knowing how to understand, write code maybe not as important as understanding how to read and edit code and make something work for you. If you find a resource that's a snippet of code and it doesn't work, you can edit it and make it work. That's kind of the goal there. And the other one is the spatial database management. Again, a lot of data, geospatial data, imagery, etc., is stored in a database. So the instructor in that program looks at some tools to give you exposure to how to work with databases, how to do queries, how to pull information from a database, and even how to manage and store information inside that database. And that's all, again, like I said, very, very foundational, fundamental stuff that I think the first semester, everything that you learn, you'll carry through your career. If you want to change to term 2. All right, so this is our winter semester. This is where things get really specific with remote sensing. Jim teaches about half, and I think I teach about the other half. So I'll just mention my courses here briefly, and then I'll let Jim talk about his, and then we can move on and talk about spring semester. I do the Advanced Digital Image Processing course and the LiDAR course. The Advanced Digital Image Processing is kind of a spin-off of the Fundamentals of Remote Sensing course, where we'll look at airborne imagery, satellite imagery, but we'll do more advanced things such as, maybe learn how to do a little bit of band math or look at remote sensing indices. We do get into machine learning, deep learning, getting into the AI stuff. It's still relatively new, but as I'm sure you all hear, it's AI is growing, and it's embedded in a lot of the software that we use here. So it's meant to give you a little more exposure, a little more scripting experience as well, to automate some of these processes. The LiDAR course is, again, an introduction to LiDAR right from the operations aspect. So, if you were, your job was you were part of the crew who was collecting the LiDAR, we start off the course with, okay, let's say we're out on a field project and we collect our data. This is what goes on with the planning and the field work and how you process the data that comes off the aircraft onto QA, QC, deliverable products and deliverables, and maybe a couple of applications I think we squeeze in there at the end. So the courses are quite full. You can see that those 2 courses are 5 hours a week. So you'll be pretty immersed in those. I think I'll let Jim discuss his courses.
Sorry, I pushed my controls off to the side there and then buried them. So to just give you a bit more depth in the airborne survey course, you can see Tuesday afternoon, Friday afternoon there. What we'll do is we take what you already know and basically add some more information to it, but in particular about planning and collecting an airborne survey. So there are lots of components to that, not least of which are the legal components of actually knowing where you can fly and with what machine and so on and so forth. So we do talk about the Canadian RPAS, or remotely piloted airborne system rules, from Transport Canada and how we fit into that. And then we basically do planning and actual research on planning an airborne collect as if it were from a plane or through a drone or RPAS. They're slightly different, and we basically discuss what are the the planning considerations for both systems, so you have a working knowledge given a certain set of circumstances, which is the better of the two, whether it be a drone-based or RPAS survey closer to the ground in a very confined area, or a much larger airborne survey. Of course, we do talk about satellites as well as another source of remote sensing data, but that's not the primary kind of concern of this particular course. Okay, so we take you through to the point where you're actually able to start to process some of the data. Now we take it from the stance of the beginning, like knowing nothing about it really. We start to use these semi-automated tools at a very kind of low level, and then we get progressively harder. So we start to do what used to be known as soft copy photogrammetry, which is basically using the aerial photographs from planes predominantly. And there's a historical context to this as well, where air photos have been around since the early part of the 20th century, really the 1920s. And so there's a whole archive of data, which is in a historical context very important to be able to process and get information from that, from those data sets. And so we teach you how to do that in this soft copy photogrammetry component of the course. So it's old school analog aerial photography, which is kind of cool. And we have some data sets and so on, and the software to be able to go and do that. We then move on to digital aerial photography, where there's more involvement of something called direct georeferencing. So it's digital, it's using the survey grade GNSS or GPS systems, and then we'll be able to create the mosaics of the air photos that are subsequently used for mapping or other kind of gathering of information, to the point where we're able to do data extraction and updating 2D data sets to 3D data sets, doing some work in stereo, that kind of thing. And then ultimately leading on to the capstone project, which is basically, and I know we're crossing over now into the third semester a little bit, because we start to plan the first collect of the field camp, if it's going to go that way, as the capstone project for this course, the airborne survey course. It may change a little bit just based on the dynamics of how we're having to do field camp and so on, but that's basically it. And that capstone project is run in tandem with the applied project course, which is one of the other courses that I instruct on, which you can see there on Friday mornings. I'm just looking for it somewhere else, if it's anywhere else. Oh, sorry, Wednesday morning and Friday morning, applied research project. So this is basically a project management course. It's predominantly predictive project management, not agile, if you know anything about that. And so we basically take it from the beginning of a project all the way through to the deliverables and the reports and so on at the end of the project. But it's applied to a remote sensing project. So there's a lot of peculiarities, if you like, nuances, you may say, in a remote sensing project, and we'll talk about those. And so you're kind of then experienced enough to hopefully go take on remote sensing projects and know what the considerations are with regards to things like quality and collecting ground control, and all these kind of things that you have to consider when doing remote sensing based applied projects. Okay, so that really talks through the two courses there, airborne survey and the applied research project, and they work together all of the time. The other one is the remote sensing systems and applications, and it's kind of easy to think about this one as the kind of the space where everything else goes, but that's not quite true. But it kind of is. There's basically two major technologies that we cover off in a lot of these courses, and that's basically the LiDAR and then the imagery or the pictures. And there's these two big technologies, but what the remote sensing systems and applications does is it takes what you already know from the first semester in terms of the spectral content and moves that a little bit further forward, starts getting into more multispectral systems, so systems that are designed from the ground up. We talk about hyperspectral analysis. We talk about spectral analysis with a spectrometer to measure light. And what systems you need, what factors you need within a system that you can design from the ground up, kind of thing, with the spectrometers. We'll talk about thermal remote sensing as well. Radar is a large part of remote sensing systems and applications, where we'll actually do we'll plan a radar collect, or rather you will, of a place of interest that has shown some kind of deformation or change over time, and will actually get you to download the data, process through these deformation maps, and be able to show how much deformation or change has occurred in the landscape, and then validate it later on with space-based laser altimetry or like LiDAR data from space. So it's, again, there's lots of different technologies creeping in here. I'm trying to think if I've forgotten any on the fly here, but I've mentioned hyperspectral, mentioned the true multispectral, and the radar. So that's pretty much it. But we touch on a lot of different things. So there's a lot of different components to that remote sensing systems and applications, all of which are based upon the premise that you've come from a degree, and maybe that degree, I'm going to pick on the geologists again, maybe that degree is geology, and so all the time we go through that remote sensing systems and applications course, we're talking about different technologies as the weeks progress, and then your job in your term project for that course is to research how that technology has had or could have an impact in your field of interest. So again, if it's the geological context, how does thermal remote sensing play a part, or how could it, or how has it? Again, at the end of the semester, we'll ask you to give a presentation, and they're usually pretty interesting points of view on how these technologies could have an impact in your fields of interest. Okay, so that's pretty much it for me.
Excellent. The spring semester. So after, and you guys, you saw the terms are pretty full. That doesn't mean, if we have you for 5 hours a week, it's not myself or Jim talking at you for 5 hours a week. A lot of that is meant to be, you guys work on some stuff. We're here for support to answer questions. We can talk about that a little bit later. The spring semester, you have a few options here. So this is like our short term, our 5-week semester at the end. In the online environment, you can do work integrated learning. We don't have relationships with clients, so for the work integrating learning option, if you find some work that's relevant to our field, GIS remote sensing survey, you can get out and start working, and that would meet basically the learning outcomes for that option for the spring semester. The other option is the capstone project, which would be just a 5-week project. It could be something, we typically have a list of project ideas for students to choose from, or you could have something independent for just something you're interested in, or if you have a real world client. There's several options there, but 5 weeks is, that's a pretty short amount of time to get through something. So lots of times, we probably encourage you to investigate something you're interested in or whatnot. The last option there is our field camp. And I'm going to strongly recommend this one. I understand, if you have to travel here to Lawrencetown from far away, that might be a challenge, and that's why the other options are there. But the field camp gives you an opportunity, and I believe will open doors for you upon graduation, because this is the time where you can come to COGS. We've been told that there will be rooms available in our student housing, so accommodations would be there. You have to plan that out in advance, but in the field camp, you come here. This is when you get your hands on all the equipment. So the stuff that we would have showed you in the spring and winter semesters, that would have been from data that myself or Jim or other students from before have collected, and we'll use it as kind of our demo data sets. If you come and we go out and, we'll have to go over some of the concepts of GNSS, but we'll get you out there collecting static data, collecting RTK data. So using the actual survey equipment that you would use in industry if you were to do field work in industry. We also have several drones here. We have a multispectral sensor, we have a LiDAR sensor, we have RGB sensors. We have lots of tech here. And if you go through, I believe in one of Jim's courses, he'll probably strongly recommend that you get the basic RPAS certification, so your basic drone license, basically. And then when you come here, you can actually fly our drones. So typically, we will go out and maybe find a little project. It might even be on campus where you can plan your own project, fly the drone, process the data. So go through the whole workflow is what we're trying to do, right? Right from the planning stage to the actual acquiring the data, to processing it, to doing the validation or the accuracy assessment piece, and then creating some products or deliverables, which will be a pretty standard workflow for any kind of project you would do in the industry. So we'll see what happens when we get there. I'm hoping to get a big turnout for field camp because it's my favorite time of year for sure. Do you have anything to say about the spring semester, Jim?
Other than it is a capstone in and of itself, in that there are things that we will be going through in a kind of we'll be basically giving you tuition, but at the same time you'll be covering off all of these learning objectives that you would otherwise have done in person. So it is a instructional time, but it's also a time to experience some things that are slightly more technically demanding, and practice them in the field and do it within the processes that we've already established in the previous courses, such as the project management course and so on, so that we take on things and we'll define the deliverables and go through all of that, and at the same time teach you how to put up a tripod or fly the drones and so on, and go through all the safety considerations and so on. So at the end of it, hopefully you'll have the confidence to go into the next phase once you've left COGS, and without that worry about, well, I don't know whether I've got the hand-eye coordination to fly a drone. You'll already know that because you would have practiced it here with us. So it's really hands-on kind of skills-based experiences that you'll get.
So I guess the workload portion, it is significant. It's a lot of information we're trying to convey to students in a relatively short amount of time, right? It's not like university. If you're coming into university, the NSCC and COGS, it's not heavy. There will be some theory, but it's more about the practical hands on the software, hands on the equipment, more actually doing stuff. And that's, the goal is so you're prepared for industry. When you graduate, you should be able to hit the ground running, for lack of a better way of putting it. So the workload is significant. I think if you plan for every hour you've got in class with us, you probably have an hour of homework or time where you'll be working on an assignment or a project or something like that. I think that's a fair estimation. You should try to, stay on top of everything. I think, well, what I'm trying to think here. I guess I'm trying to say, to answer some of these questions, because we always get questions about, well, what can I work and do this? I know times are tough economically out there for lots of folks. You could probably get away with a part-time job. Working full-time and trying to do this, I don't think is a good idea. We've had folks try it before, and typically they're not successful because it's just really hard to keep up with all your coursework and then try to manage a job as well. Some part-time work, that might be doable. I think that the layout, the way we run our courses is you would get some practice time, we do some demonstrations, we go through some stuff together, then you would have an assignment, and then that would be your evaluation. So it's kind of, preparing you to do a little something with some data. Then you go do your assignment on your own. And when I say on your own, that doesn't mean we're there to help and support you. But yeah, and that's it. It is going to take some engagement. It is synchronous, so it's virtually you're in a virtual classroom with us. Jim?
Thanks, Rob. I think the biggest thing I can add to this is just understand that you do have time in class to work on things as well. It's not like it's full. We're not full on like fire hosing you for 5 hours a week. That's way too much. So you'll maybe get a few hours of tuition and have a few hours within class time to work on it. But that also, means that you're going to have probably going to have some work to do outside of class time as well. So please don't come expecting to be done at 3:30 every day. That's just completely unrealistic and it isn't going to happen. And there are things that do take longer, and you think you've got a good handle on it, and then something goes wrong technically, and you just have to spend time to figure it out. That's one of the big things. One of the big takeaways will be a healthy work ethic you'll take away from here, and also the ability to work around problems. And that's key to this entire industry is robustness. So you can take a hit or two, and also the ability to work around problems. One of the biggest things we're actually going to do, hopefully, is instill an idea about critical thinking. So the fact that you can't necessarily rely on data sets without testing them, where did it come from, and so on and so forth. And that goes for information as well. Probably good a time as any to mention artificial intelligence. We support the idea that AI is out there and it's a good resource, but that needs to be proven. It needs to be taken critically, thought about critically, and proven before we can accept it as being correct. So that's something to bear in mind as well. If you're really heavily into AI, that's fine, but we need proof. We need categorical proof that what you're saying is correct. So most of that is kind of on the periphery anyway, because we're doing something, and so we're proving that the thing that we've done is correct by taking measurements. That's very difficult to do on AI. So a lot of it is kind of a moot point talking about AI, because we're asking you to do the thing. And if you haven't done the thing, it's pretty obvious. So that's really all I can kind of add to that. It is challenging for sure. And it's kind of immersive. You once you get into it, you're just thinking about it all the time and thinking your way around problems and so on, which is how we think you need to be getting into the industry.
All right, so as far as what you might need, we don't have any required textbooks. There are a couple recommended books that we refer to. We'll share information with you. In Brightspace is basically the learning software where all the course resources and everything will be. So we can share some information with you. There's lots of open source information online. So nothing required, but there's a couple recommended. So should you come across the Remote Sensing and Image Interpretation book by Lil Sand and others, that's a good book. And the Jensen's book, Introductory Digital Image Processing, also a really good resource. I think, for online folks, you're going to want to have a decent computer. And this slide has kind of minimum specs, 32 gigs of RAM. If you have a dedicated GPU, a lot of the photogrammetry and a lot of the stuff we do in a 3D environment, having a good graphics card really speeds up processing. It will work on other lesser machines, but it just takes a long time. And you might find that to be a little bit frustrating. I'd recommend something with a terabyte solid state drive. I also recommend dual monitors, because a lot of the software has many windows. Sometimes you might want to have a PDF open on one monitor, your software open on another, to follow instructions. I just recommend dual monitors if you can pull that, you can work that. Of course, a webcam microphone. It might not be a bad idea to have an external hard drive to maybe back up your data as well. And I think that's all I could think of.
If I could just add to that, you'll have access to Microsoft OneDrive as well. The temptation may be to back up to OneDrive, and it does work if you've got a strong enough internet connection. But we found that there's a definite lag in downloading files or uploading files even to OneDrive. So having that external hard drive physically attached to your computer is a much more efficient way of just backing stuff up. And making a duplicate copy as a backup, as opposed to using something like Windows Backup, which is kind of, it's maybe you'll get the data back, maybe you won't. And a lot of people do use like OneDrive for this small files, but just remember we're utilizing data sets that are, sometimes hundreds of gigabytes in size. So it won't take long to fill up one terabyte, especially if you're keeping all the interim data sets along a process. It will fill up pretty quick. Okay, that's all I have to add to that.
Good, thanks. I think this is more of a college-wide thing than specific to our program, but I mean, some tips for success. There's a little bit of math, of course, reading, some research will be an important part of what you're doing. There aren't a lot of tests that I'm aware of. There might be a few quizzes, things like that. So basically, be ready to do academic stuff. I will, the second point there, attend classes. That's really important. As instructors, we like to have people who are there engaged with us, so you can ask us questions, or if we're working through an assignment and doing a demo, it's important that you're there when we're scheduled to be there as well, because we teach in other programs, like Jim said earlier, so we're pretty busy. So it's important to try to use our time most effectively, as effective as we can anyway. We will have events, so we'll have an industry expo. Lots of times there's a guest presenter, things like that. There's always something on Teams. So even if you're online, you can still attend these events virtually. And I think there's a lot to be taken away from that, because you get good exposure to, hey, this is what folks are doing out there in industry, or sometimes folks come here to recruit. Could be an opportunity to introduce yourself, build a relationship, maybe get an interview. It happens every year that students get hired before they're finished. Otherwise, I mean, the main tip for success is to be engaged, and I think you will. I mean, students tend to become immersed in it and enjoy it. 8 months is a really short period of time. Jim?
Thanks, Rob. I think if anything to add to this is to kind of emphasize the importance of being there when the classes are on, because there's always a lot of stuff that's discussed or shared around and so on that you may lose the context of if you're not there. Relying on third party or recordings, it doesn't give you the full kind of picture of what was discussed at the time that the issue was raised or what have you. So I think it is duty bound, but also practically much better to be there and attend the classes and ask as many questions as you can. It's a little more awkward in a way to ask questions online instead of when you're in a class with people that you know and interact with on a daily basis. It's a little more awkward, and we get that, but it's just as important. In fact, some cases more important to ask those questions, because everybody's in a little bit of a silo wherever you are. And somebody asks a question and says, oh, that applies to me as well. And you're only really going to get that really 100% when you're there in person and engaged and closing down all your other distractions as much as possible and just concentrating on what we're talking about. That's really the best way to get through all of the work. Because later on in the evening, when you're trying to work on something, we may have discussed something earlier on that just gives you that piece of information that's critical to you carrying on and getting done and going to bed that night, and you may have missed it, and that's not the time to find out. So attendance is really key to this. It is going to be busy, so turning up, in class is important.
Okay, the last little bit, I'm just kind of aware of the time here now. The grads from this program are in high demand. In previous years, we've had students who have interviewed and have been hired before they finished. That's not to say that they left the program. Just means that they finished the program, but they knew upon completion they had a job waiting for them out there. So, all the stuff we do in the fall and winter semesters and spring semester is meant to prepare you for whatever niche of the industry you're going to enter, and you should be able to, get into whatever position you're doing and be relatively comfortable based on all the stuff you've done with us to, use software. Every job is going to give you some kind of training anyway, but you should have a really good tool set to be comfortable and confident in whatever company you end up working for. So on the slide here, I've just got a few of the employers that have hired some of our grads, and this is just a small sampling. And the job opportunities are, honestly, it's a very wide range. It could be something from like a GIS technician to do GIS work. It could be something to maybe even doing, operating an airborne LiDAR system or an airborne camera system. Actual field work. If you're more into coding and programming type stuff, there's also that niche of jobs out there. So, I mean, again, like we said before, depending on your background and your interests, I think with the GIS remote sensing graduate certificate under your belt, there's a whole bunch of stuff you could potentially do.
Okay, I'm going to jump in there before you say anything. Think about it in terms of marketable skill sets. Is always what we try and discuss a little bit with anybody that's doing the things that we do. Flying the drones, taking survey measurements, and so on. These are all things that are marketable. So when you have it on your resume and you've already got your certifications from Transport Canada and so on, so you're all checked out and you're experienced, you've done project work, so again you understand where you fit within the industry and the project management cycle. All of these things kind of come together and just make you a better hire. So when you've got these things on your transcript or your resume, again, they're key things that make you more marketable to actually gain employment in our industry. Okay, that's all I have.
All right, that was great. So I'll just touch briefly. I know I've seen a few people joining us after we started, so just a reminder that if you have any questions, you can start putting them in the question box since we're about to wrap up the session. So just to know that if you complete this graduate certificate in remote sensing, it is equal to the first year of a Master's of Science in Applied Geomatics from Acadia University. So that's a really great route to take, that if you're planning to pursue your master's, this program is equal to the first year. So just something to keep in mind if you're looking to advance your education as well. And then just a little bit about the not so fun stuff, which is the tuition costs. So for domestic students, this graduate certificate program, the base tuition is $5,540. So that's your base tuition amount. But then there's also program fees. So I know Rob and Jim have talked about these fees and like the computer and that kind of thing that would be part of it. So this is just a snapshot of your approximate costs for those things. So on the left-hand side is our base tuition and college fees. So these are applicable to any NSCC student. although they are a little bit flexible. So if you look at things like your health and dental benefits, if you have coverage through a parent or a family member or previous work, you don't have to opt into our health and dental program. Same with a parking pass. If you're not planning as online students to park on campus, you wouldn't have to purchase a parking pass fee. So just things like that. And then on the right-hand side is more specific to the remote sensing program. So we talked about the computer, the webcam, those kinds of things. And then other things to consider is your safety vest and your work boots and that kind of thing. So all of this information is available on our website. So the website down at the bottom there, nscc.ca/program fees, and you could just scroll down to remote sensing, and they'll all be listed there as well. And you'll also see the tuition amount for international students there as well. So I encourage you to check out the website just to get a full rundown of the fees and costs to attend to this program. And that being said, we do have lots of scholarships and bursaries available. So you can take a look now, even if you haven't applied, at our awards site, which is listed down at the bottom there as well. Our awards are based on a series of criteria, so it's not always your academic standing, especially since our students are coming from typically a university or a college for this program. So it could be based on your financial need, your leadership skills, any volunteer work you might do. So I encourage you to check out the website just to see what's out there. Again, when you're budgeting and deciding if you're going to join us, it's a good way to kind of see what kind of awards and bursaries you might be eligible for. We mentioned this as well, but there is housing available at the COGS Center, so that's a really great benefit, especially for your fieldwork component, like Rob mentioned. So you would be doing your fieldwork in the spring semester, so there would be rooms available at this housing, or you might choose to attend stay in housing for the whole year, even though it is an online program, but you want to be close to the action. You're welcome to do that as well. So just to know that there is a 35-bed facility at COGS that is open to students in this program. So hopefully we've convinced you to apply today, but just a quick rundown on how to apply. So if you go to nscc.ca/apply, that is where you will apply from. You can choose up to 2 program choices. So they are ranked, so you would choose your first choice program and your second choice program. Because this program is a graduate certificate, you will need to submit your transcripts from the post-secondary institution that you attended if it's somewhere other than NSCC. And check out if there's any other admission requirements. If there's a seat available, you will get that seat. And then you'll pay your tuition deposit and join us in September. So it's a pretty simple application process, but if you do have any questions about it, you can email the recruitment team. We're happy to help you through that process. Okay, so we've come to the end of the session. These are our email addresses. If you have any questions after the fact that you might think of later on, we're always happy to answer them. I don't think we've gotten too many questions today, but we do have one here asking, and this might be more of a follow-up question. We might need to do a little more research, but curious if Rob and Jim have this experience. Someone's asking if the marine navigation technology program from NSCC would count as an admission requirement. It's not listed as a field of study. However, that program is a diploma program. So I'm not sure if you guys have seen students come from that program. I can certainly ask our admissions team to clarify as well.
Not that I'm aware of, but it's a diploma program, and navigation, it's relevant in my mind. So if I was the admissions person, I would say yes.
I would too, but
Yeah.
don't want to give a definitive answer.
Yeah.
So if you want to take that question, and you can send it to recruitment@nscc.ca, I'm happy to give you an official answer once we check with admissions, just to be sure. But in my mind as well, it's a 3-year program, very relevant to remote sensing, also Transport Canada program. So, and let's just see, I don't think that might be the end of our questions, actually. But I know this was a lot of information, so if tonight or tomorrow you're kind of reflecting on what you've heard today and you have a follow-up question, you're welcome to email any of us and we're happy to get an answer for you. And thanks so much for joining us today or tuning in after the fact. And we hope to see you at the COGS campus in September. And I want to thank Jim and Rob for being here today and sharing their expertise with us. I'm sure I've learned a lot, so I'm sure the attendees have as well.
Thanks, Jessica.
Thank you.
Yeah. All right, thanks everyone. Enjoy the rest of your day. See you.